And welcome back to Mr. Gregoris Math. I can't believe I didn't have a video of this one already. Mr. Poliquin's in here just low-key chirping me for not having videos for every single math topic that we've got. I've got a thumbs up there. So we're taking a look at finding exact values of trig ratios, and we're going to do this using our unit circle and our special triangles. But I'm going to get a little lazy with drawing our triangles, and we're going to follow this pattern of draw, triangle, and SOHCAHTOA. Of course, we would have to reverse this if we were talking about cosecant, secant, and cotangent, but we're just going to stick with these for now. So the first thing I do is I draw the angles. So in this case, part A is sine of 5 pi by 6. And you could have these memorized, or you can just draw the angle. So here's 5 pi by 6. It's right there. It's one that ends in 6, so it's close to the x-axis. I'm now going to draw my triangle. This is the shortest side length, so it's 1, here's 2, here's root 3. So I know sine is the opposite over the hypotenuse. So in this case, my sine is 1 over 2. Now, I do need to verify my signs or SIGNs as well too. And I can do that using my cast rule. So cosine is positive down here. All of them are positive here. The sine-based ratios are positive in that quadrant, and the tangent-based ratios are positive in this. So because sine is in this quadrant, it's positive here. The other thing I can do is I can notice that the line is above the x-axis. Above the x-axis is positive for sine. Below the x-axis is negative. For cosines, to the right is positive, and all the things that Beyonce wants to the left are negative. And then our tangents are always in the first and third quadrants positive, and in the second and fourth quadrants negative. And that has something to do with tangent being an odd function. Now let's go ahead and do the next one. So again, I'm going to follow my rule, draw. I draw a new one for each. This is a little bit trickier because I got to go in the negative. So there's negative 1 pi by 3, negative 2 pi by 3s is right here. You'll recognize this as being the same angle as 4 pi by 3. Now I'll draw my triangle. Here's the 1, the root 3, and the 2. Now, cosine is negative, but you can think of this negative 1 as being measured along the x-axis. So these are negatives here as well too. And cosine is the adjacent over the hypotenuse. So in this case, the adjacent is negative 1. It's always your x value. And our hypotenuse is the length along the diagonal, or 2. So the cosine of negative 2 pi by 3 is negative 1 over 2. And lastly, we're going to do the tangent of 7 pi by 4. I like to kind of take an estimate of where my angles are based off of how many times the denominator goes into the numerator. So this is almost twice, so it's almost once around the circle, because almost once would be almost a full time. Almost twice would be almost a full time around both halves. And so there's 7 pi by 4. I know that it bisects one of my pi by 2s. So my angle is 7 pi by 4, and I'll draw my triangle. And it's going to be a 1, 1 root 2, because it ends in that reference of by 4. So the tangent is the opposite over the adjacent. But again, remember, only the cosine is positive here. So this one is going to be negative 1 because it's negative 1 going down and positive 1 going over. And negative 1 over positive 1 is negative 1. So that's how we can use the draw, triangle, SOHCAHTOA technique to evaluate some special triangles. I just did 3 ratios in 3 minutes and talking you through it. I'm sure that you can do it a little bit faster than that. Do check EDSB today, as I'm going to post about 17,000 practice questions for you to do. And you'll know you're getting good at them if you're bored. Don't forget to hit like, subscribe, ring that notification bell so you can see when new videos drop. And remember, we don't say the D word, we stick with radians because we're not so self-centered.